Welcome to myprojectwizard.com. This is our project title, Big Data for Remote Sensing, Two Challenges and Opportunities. And this is our project abstract. Every day, a large number of Earth observation, space borne and airborne sensors from many different countries provided a massive amount of remotely sensed data. Those data are used for different applications such as natural hazards monitoring, global climate change, urban planning, etc. The applications are data driven and mostly interdisciplinary. Based on this, it can truly be stated that we are now living in the age of big remote sensing data. Further, these data are becoming economic assets and new important resource in many applications. In this paper, we specifically analyze the challenges and opportunities that big data brings the context of remote sensing application. Our focus is to analyze what exactly does big data means in remote sensing applications and how can big data provide added value in the context. This is our project data flow diagram. First we have to start the program. After the start the program, we have to select the data related to the remote sensing, having the remote sensing data, remote sensing image feature sets. Then we have to load the data into the store in the HDFS Hadoop storage, file storage, and then map and reduce for word count of the data sets. Data sets have what all the things having in the data. After that, we have to pre-process the data. If the data records having any null values or any irrelevant symbols or anything else, we have to remove the data, remove the complete information from the database. After pre-processing is completed, then we have to take the decision to storage decision. If it is in offline data or online data. If it is an online data, then we have to move to the offline data. Then we have to, after storage decision is completed, then we have to so filtration is nothing but we have to separate classify the unnecessary data. So the unnecessary data means we have irrelevant values of finding the remote sensing places. That's why we have to remove the unnecessary data and store it in the unnecessary database. Then we have to load balance for moving even to efficiently running the different virtual machines. We have to split the different virtual machines, and we have to separate. We have to assign the data to the virtual machines. After we have to load balancing, we have to pre-processing. The pre-processing is nothing but we have to set the data as depends on the land area datasets or not. If it is a land area dataset, we have to go to move on the analysis and the decision. We have to after analysis decision, getting the separate similar values of belongs to the land trees, something else. We have to find the decision, analysis, and shift the decision. After that, we have to store it in the result database. Then stop the program. Now we have to see the demo of our project. Click home.java, right click on it, choose run on Hadoop option. After clicking the run on Hadoop option, we have to select the VM server. After clicking the finish button, we have to the home page window will be displayed on the screen. Then home page screen will display in the window, and click here and select the data set. We have to set the land area data set. So we have to select the related data inside the land.txt, then open the land.txt, then store it in the Hadoop storage. After clicking the Hadoop storage, we can store it successfully. If you want to see the Hadoop files, means we have to see here. Here it is. Then you have to click next button to load into the database. The load successfully. Then show the data. The data will be stored successfully. Here there is. Then preprocess the data. After preprocess the data, we have to preprocess completed. Then view the data. Then click next button. After you have to click, you have to filtering the online offline data and online data. The discards the unnecessary data, so it's online offline data. Then show the data. These are all the offline data. Then online data. Then we have to check the load balance and allocate the systems. Load balance the data and show the allocated system. The machine 1 having this amount of data and machine 2 having this amount of data, and also machine 4. Then click next button to reprocessing the server to find out the data. Please process successfully. After we concatenation of all the data, we have to show the data. Click the next button. We have to analysis and decision. To take the analysis and decision, the area product cover the area and the bandwidth of the every classes like tree, car, grass, etc. Then produce the results. Find the result. The result will be found. Then show the result. After clicking the show button, we have to see the graph result of the remote sensing application data. Then the amount of trees, cars and grass, shadows and soil remote sensing areas are displayed in the screen. Then close the program. Thanks to listening this video.